Unified Computing System, UCS. So Cisco has got a server. We saw those introductions in the earlier class. Now let's get into the components. The important component here is the Fabric Interconnect. The Fabric Interconnect is the one which provides the network connectivity as well as the management capability. Meaning the ports on the interface, the Fabric Interconnect, the ports on the Fabric Interconnect helps us to connect to the upstream, which is a network, downstream, which is a server. That server may be a UCS B series, or it can be a rack mount C series. B series is the one which we have it in a big chassis inside, many blades. Like if it is full blade, 4 blades per chassis. If it is half blade, 8 blades per chassis. Nowadays most of the UCS comes, the B series comes with half blade, which means 8 blades in a chassis. So connecting these blades or the rack mount server to the network, we use this intermediate device called Fabric Interconnect. So this is not just an intermediate device, this is also a management plane for all those servers that are downstream. So if I need to put it in a picture, it will be like this. So we got a Fabric Interconnect that may be connecting directly to a rack mount server like this. This is Fabric Interconnect 1 or A, Fabric Interconnect B. It connects to the C series, on the rack it is, or it can be a big chassis inside the rack which is connected to the Fabric Interconnect, and this Fabric Interconnect is connected upstream to maybe a Nexus switch 5000 or 7000 or 9000, or it can be even connected to a catalyst switch, but mostly in data center we use Nexus switch. So that's the word mentioned here. Fabric Interconnect provides both network connectivity and management capability. The Fabric Interconnect deployed with the B series blade servers as well as the C series rack mount server. So this is what we are going to see in depth. Now, Cisco Fabric Interconnect. Fabric Interconnect provides the management and communication backbone for UCS B series blade servers and chassis. The management and communication backbone. How do we configure the servers? From the manager that we got on that Fabric Interconnect. So the Fabric Interconnect has a UCS Manager. Using that manager GUI, we communicate to the servers, and also it's the same Fabric Interconnect helps to manage the servers and the chassis. Not only that, when we connect the server to the Fabric Interconnect, all servers become a part of single and highly available management domain. So we got the single graphical user interface via which we are going to configure the B series and C series servers. So we are trying to understand the role of Fabric Interconnect here. The first thing is it communicates. It communicates with the servers connected to the Fabric Interconnect, the policies, it pushes the policies and so on. It helps to manage the servers. Not only that, we no need to jump between servers. It provides a single pane of glass for management. Plus, when we connect servers to the Fabric Interconnect, all servers become a part of a single and a high available management domain. Yes, Fabric Interconnect is highly available management domain. The reason is Cisco recommends to buy 2 Fabric Interconnect, not just one. So that if one Fabric Interconnect fails, you have another Fabric Interconnect to provide the GUI. Providing GUI is done by one of the Fabric Interconnect among 2. So we have 2 Fabric Interconnects. One is going to be, both are active when you talk about control plane, both are active. And data plane, both are active, but the management plane is only one. Either this will be providing you the management GUI, the UCS Manager, or this will be providing, whichever is primary. Now this will be a control plane for half of the server, this will be a control plane for half of the server. So in that way it has got active control plane and data plane. But some will say, data plane both are active, control plane only one will be active, that control plane will be providing the management plane. That's partially true. We'll talk about those things in detail after a few minutes. So depending on the pinning, we will talk about that. So UCS Manager will be available for you from one of the Fabric. And so there will be one common IP address, floating IP address, to get this GUI. So whichever the Fabric that is active will be responding to that manager request. You'll get the GUI from there. So when you connect the servers to the Fabric Interconnect, all the servers become a part of single and highly available management domain. It's highly available because you got 2 Fabric Interconnects. Though it is single, UCS Manager, if one Fabric Interconnect goes down, you don't lose the UCS Manager. You still have the UCS Manager provided by the other Fabric Interconnect. It's highly available. UCS Fabric Interconnect supports unified fabric, meaning you can connect to a LAN, Ethernet, you can connect to a SAN, fiber channel connectivity to all the servers within the domain. So it helps us to talk to both storage as well as the Ethernet network. Next, this Fabric Interconnect with servers and chassis connects with the unified fabric through unified port. So you got a unified port. What is a unified port? The port that can be Ethernet, it can also be fiber channel. That is called unified port. That's what here I explained, which may be a Ethernet, or it can be a fiber channel transferred over Ethernet, or it can be a native fiber channel interface. So it can be a Ethernet or fiber channel. That is what unified means. You can have it as a plain Ethernet port, or you can convert it as a native fiber channel interface, a fiber channel port, or you can keep Ethernet. On top of Ethernet, we can transport FC, fiber channel. So the ports that are in the fabric interconnect that connects to the chassis and the server can be defined as an Ethernet port or an FCOE port or a native FC interface. So actually, if you go under the fabric interconnect tab, actually you will have a tab called hold on. So in the home page you have equipment tab. When you click on this equipment tab, you will see fabric interconnect listed here. Right now equipment is not it is under chassis. Okay, here it is, fabric interconnect. Sorry, it's under equipment only. I thought server is selected. No, it's equipment is selected. You can see fabric interconnect primary, which is going to provide you the UCS Manager, and then the subordinate fabric interconnect B. I know it should be very small for you to see. Oh no. Let me try back. Yeah. So this is what I was talking about, fabric interconnect under the equipment tab. And when you click this one, it drops down with the list of ports. And when you right click the ports, you will have an option to configure like server port or uplink port or FCOE port and so on. I think this is the one. Yeah. This is an older version of UCS Manager. But this is what I was talking, but it's too tiny for me. Even here also you can see that. This is also another way of configuring. Let me maximize. You see, server port, uplink port, FCOE up port, storage port FCOE, appliance port. These are the options, various options that you have. When we get access to the lab, we can easily see this. But this GUI and this GUI, this is different. Both are UCS Manager. This is the newer version. This is how the newer version will look. The older version looks like this. Yeah, that's the difference. A big difference, right, in the appearance. Fine. So let's go back to our. So any port, they are unified port. That is what we need to understand here. They are unified port. You can take any one port and say you will be an uplink port for me, or you will be a FCOE port for me, or you will be a FC port for me, or you will be a server port for me. Server port and Ethernet port is different. Server port is the one which connects down towards the server. The uplink port is the Ethernet port. Uplink port is the one that connects to the network. Uplink port is the wire that connects to the uplink, upside. Let me draw another picture. Fresh page. So I got a fabric interconnect which is connecting down towards the chassis. So what do you configure these ports? These ports are called as server ports because they are connecting down to the chassis. And this port that is connecting upward, any port, you can take any port. You can also take this port and connect to a server if you want. But whichever you connect to the up, you need to configure it as an uplink port, this as a server port. You just define it. That's our first lab that we're supposed to do. This is all because these are all communicated through the fabric interconnect. That's why the first point says to communicate to the blades and chassis, and also to manage, we need fabric interconnect. Next, fabric interconnect and Cisco UCS Manager. UCS Manager can run on single fabric interconnect or on a redundant cluster. So even if you have a single fabric interconnect, you will have a UCS Manager. But the problem is, when we have only one fabric interconnect, if that goes down, no servers will be able to access. You will not get UCS Manager. So if you have a cluster, means redundant fabric interconnect, high availability will be there. So servers will be still reachable via another fabric interconnect. You will have a UCS Manager up and running. So you may have UCS Manager on a single fabric interconnect or a redundant fabric interconnect. UCS Manager enables fabric interconnects to fully manage all UCS components like server provisioning, meaning the servers get attached to the manager. Manager can see the servers, and also it can discover the devices that are connecting to the fabric interconnect. Servers are downwards. You may be connecting a storage box. Fabric interconnect can discover it. You may be connecting a Nexus devices on top, a router on the top. Fabric interconnect can discover inventories, and it will make a note of all the discovered devices. Helps to diagnose, helps to audit. You can see the health scores and so on using the UCS Manager that runs on fabric interconnect. Now, UCS Domain. Use a single fabric interconnect with a standalone configuration. You may have UCS with a single fabric interconnect, or we may have a redundant pair of fabric interconnect in the cluster configuration. Why do we need? For high availability. So cluster configuration. Cluster configuration actively enhances the failover recovery time for the redundant virtual interface connection. So what is virtual interface connection? VIF, or the one which connects to the blades. The blades. Each blade has got not the NIC card, but the VNIC card, virtual NIC card. We call it as VIF, virtual interfaces. So cluster configuration actively enhances the failover recovery time of the redundant virtual interface connection. What does that mean? That means, you see, these are all the connections that is going from the FEX module. This FEX, we call it as FEX, or you can also call it as IO module. Yeah, so FEX module or IO module we have at the back of the chassis. Now at the front you might have seen 8 blades. From 8 blade we get multiple virtual NIC cards and virtual HBA cards. NIC card, you know what is NIC, network interface card. HBA is host bus adapter for SAN traffic, for FC traffic. So VNICs and VHBAs are the one which is going to communicate to the network, not the physical NIC card. Fine. Now those NIC cards, one of the, if this is a blade, one of the NIC card will be connecting to this one. The other NIC card of the blade will be connecting to this one. So this is the blade. At the front side you have a blade. Each blade will have connection to both I/O module, and one will be pinned to the fabric interconnect A, another will be pinned to fabric interconnect B. But when A is active, B will be a standby. When the fabric interconnect A goes down, this becomes active for the server. That is what this means. This means what? Cluster configuration, meaning having more than one fabric interconnect, enhances the failover recovery time for redundant virtual interface connections. We got redundant virtual interface connection on each blade. 1, 2. So only when we have two fast fabric interconnect, the redundancy will be there. If I have only one fabric interconnect, it's of no use. If that one fabric interconnect goes down, then we don't communicate. Adapter can have an active VIF connection to one fabric interconnect and standby VIF connecting. I explained you already. So one will be active. This will, if A is active, for that blade B will be standby. If for one blade B is active, A will be standby. Yeah. So adapter can have an active VIF connection to one fabric interconnect. Active VIF connection to one fabric interconnect standby. Right. Next, do you understand this point? Please ask me a question. If you don't, I'll explain you.
No, it's perfectly explained, and of course, running through my mind is, do they have any options for active? But that's another topic.
No.
But I understand exactly what you're saying. Yes.
Yeah. Active is not possible for one single server. For definitely both are going to be active, but both the fabric interconnects are going to be active in a cluster. But if the fabric interconnect A is active for server 1, B will be standby for server 1, and B will be active for server 2, and A will be standby for server 2. In that way, fabric interconnects are sharing the loads equally, and they are active.
So it's like HSRP, let's say, for example, right? Something like that. Similar.
Yes. If I take 8 servers, 4 servers will be actively forwarded via fabric interconnect A, and the other 4 will be actively forwarded via fabric interconnect B. When the fabric interconnect goes down, A goes down, all 8 servers will be dynamically pinned to fabric interconnect B. There is also static pinning, which we will talk about that later. It's coming. But dynamic pinning, when we do dynamic pinning, half of the servers will be mapped to fabric interconnect A, the other half will be mapped to fabric interconnect B, and when one fabric interconnect goes down, all will be mapped to the other one. Did you understand that part?
Can you repeat the last part? That's the part I didn't catch too well.
Yeah. If I have 8 servers, 4 servers will be pinned. 4 servers will be mapped to fabric interconnect A. The other 4 will be mapped to fabric interconnect B. In that way, both the fabric interconnects are actively taking the load, and if one of the fabric interconnect goes down, say for example fabric interconnect B goes down, Now all those servers which was mapped to B will be now dynamically mapped, and necessary ARP request response will be done immediately for the packet forwarding to go through Fabric Interconnect A. So Fabric Interconnect A will take the load of all 8 servers, and when the Fabric Interconnect B which went down comes back, automatically the servers which was earlier mapped to Fabric Interconnect B will be getting mapped dynamically by decommissioning from Fabric Interconnect A. Those things happens dynamically.
Got it now. Thank you.
Thank you. So let's read the second line one more time. Adapter can have an active virtual interface connection to one Fabric Interconnect and standby VAF connection to second one. So at the same point, at a time from a server, it cannot communicate via two Fabric Interconnect. It uses one as active, the other one as standby. Next, learning MAC addresses are active VAF and replicated but not installed on the second Fabric interconnection. So what does it mean? For example, server 1, server 3, server 5 and server 7, let's say. These are mapped to Fabric Interconnect A. And the other server 2, server 4, server 6, server 8. These are mapped to Fabric Interconnect B, let's say, through these wires. That's how they are mapped to the Fabric Interconnect B and A. The MAC addresses will be learned for these servers. The MAC address will be learned on Fabric Interconnect B, will be replicated to A, but A won't be installing it into the MAC table. It will be there in the buffer. Likewise, the MAC addresses of these servers and the traffic that is coming from the upstream, those MAC addresses also, if it is for this server, it will be mapped on this, it will be learnt on this and installed on this, replicated to this, but not installed on this. When it will get installed, in case if the Fabric Interconnect A goes down, B will know that A has gone down. So those MAC address which was earlier got replicated from Fabric Interconnect A will get now installed into the MAC table immediately, so that even these servers can go through B. That's what it means here. Learning MAC address of an active VAF. I told you, active VAF. Not all the servers will be active on one Fabric Interconnect. For the active VAF, it will have the installation of the MAC table, and it will also replicate to the standby, but the secondary, the standby, will have the replicated copy, but it won't install it. If the active VAF fails, the second Fabric now installs the replicated MAC address and broadcasts them to the network. This we just now saw. So this is how the high availability works. This is the reason why we need two Fabric Interconnect. Please ask me a question if you don't understand any of this point.
No, everything so far is clear. Thank you.
The cluster configuration provides redundancy only for. for management plane. I told you earlier, both the control plane and the data plane are active on both FI. We got different set of servers mapped to different fabric interconnect. But the management plane, only one fabric interconnect will be responding to the management IP address. Which one? The primary one. If the primary one goes down, the secondary one will become primary and respond to the management plane. So the GUI comes from one of the fabric interconnect. The UCS Manager GUI is retrieved from one of the fabric interconnect, the primary fabric interconnect. Between this primary and secondary, between this fabric interconnect A and B, interconnect A and B, they keep syncing. Using cluster configuration. So first of all, we have to enable the cluster mode. If you are deploying this, we need to enable the cluster mode, and then we need to connect cables like this. The cluster configuration must directly connect to two fabric interconnect using Ethernet cable. So you cannot have more than two. Only two fabric interconnect, and we need to connect this two fabric interconnect using the Ethernet cable between L1 and L2. See, there is a port called L1 port and L2 port on all fabric interconnects. Let me try to show you. So what we see here is a picture from the Google. Let me use the sniffer. It's okay. So what we see here is, we can see this port is an L1 port of fabric interconnect 1. We connect a Ethernet wire to L1 of fabric interconnect. Likewise, L2 to L2. That's how we have to connect. The other are management ports. You got one L2, one L1 ports. So cluster configuration must be directly connect the two fabric interconnect using the Ethernet cable L1 to L1, L2 to L2 for high availability. Next is connect the fabric interconnect directly through the patch. In case if you cannot connect them directly like this, you can connect through a patch panel. Both fabric interconnect in the cluster configuration must go through the initial setup process. Yes, as I told you, we have to enable the cluster mode. Both fabric interconnect, if you are connecting two fabric interconnects, we need to enable it first. Enable the first cluster configuration, and then set up the second, and then which will detect the first as the peer. So first enable the first one, and then configure the cluster, and then enable the second one. Second one will be detected by the first one. Yeah, second one will detect the first one. First enable the first one, and you say, well, when you configure, initially you will be doing through a black page, through a CLI. There you will say whether I have cluster or not. One fabric interconnect or two. When you say cluster, when you say two, and it will ask whether this is the first one or the second one. You will say first one. Fine. And then when you configure the second one, it will ask whether it is the first one or second one. You'll say second one. And because the L1 is connected, L2 is connected, the second one can now detect the first one. Does it sound good? Do you understand? Any question?
Yes, I do understand that. Yeah, makes sense.
Yeah. Let's do next. This is what exactly, cluster interconnection, additional fabric interconnection. So when you connect the additional switch, you need to first install the first one, and then install the second one. Second one will recognize the first one. Next, B series. See, we have B series. B series is nothing but rack mount. Rack mount servers, they don't need UCS Manager actually. They have inbuilt GUI called SIMC. But if you are willing to connect this UCS B series, what is B series? The chassis, the rack mount. If you are connecting this UCS B series, the rack mount, to the fabric interconnect, then you will not be able to use chassis. You will not be able to use SIMC. SIMC is one of the default GUI, default manager for UCS B series. If you are using fabric interconnect to manage the B series, you will not be able to use SIMC. You can use either this or that. The rack mount B series connectivity. Fabric unified port mode. I'm sorry. B series is blade series, ours, the one which we are talking about. I was talking about C series, but I was mentioning B series. Sorry. B series don't have SIMC. C series only have SIMC. So let us not get into C series now. Let's focus on the normal chassis which we were talking about. The big box with the 8 blades, the chassis. This is B series. So how the connectivity goes. A few minutes before also I explained you the connectivity. Now I am repeating again. We got fabric unified port mode, meaning it can be an Ethernet port or it can be a FC port. That's why it is called unified. If it is Ethernet port, you can say it as a server port, the port that connects to the downstream, to the chassis. Or you can say it as a uplink port, the port connects to the nexus switch or something on the top, or catalyst switch or some switches. Monitoring port is the port for spanning switch port analyzer for port mirroring. So these are the different types that we can configure a port. You can take any port and you can define it as a server port or uplink port or a monitoring port for Ethernet. Any question on this?
And I'm just a little confused with the UCSB because we were going over the previous one is the C series, right?
No. So far we have covered only B series, blade series.
Okay.
Blade.
Okay. I got confused there. Okay.
C is rack mount. C is rack mount because it is managed through SIMC. C. That's where the C comes. SIMC is one of the management tool, not the UCS Manager. So we have seen so far only B series, and we are going to see B series for another couple of slides. Later comes the C series. C series is a rack mount. B series is the chassis based. What we are learning is chassis based.
Perfect.
So about the port, about the port connectivity, do you have any question?
No questions on the ports. That makes sense.
Right. So, same thing, explain in detail: server port, uplink port, monitoring port. Server port, the data traffic between the fabric interconnect and the server. Adapter code on the server. Uplink port, the Ethernet traffic between the fabric interconnect and the next layer of the network. It may be a nexus switch or catalyst switch. Monitoring port, mirror the traffic to these ports. Span ports. Uplink connects the fabric used to connect the fabric interconnect to the upstream Ethernet switch. FCOE port used to carry the fiber channel over Ethernet traffic. Appliance port, if you are connecting to a storage box or anything that uses iSCSI for communication, they need to be configured as the port type called appliance. If I want to connect a NetApp storage box directly to the fabric interconnect, is it possible? Yes, it is possible. We need to configure the port as an appliance port. If you're connecting a switch to the fabric interconnect, then the port needs to be an uplink port, uplink network port, uplink port. Yeah. FCOE to carry FC traffic over Ethernet. Server port is the one which connects downstream to the server. Okay, here is a screenshot. I also showed you from the Google. You see, when you open the fabric interconnect, I showed you earlier fabric interconnect. When you open that, you will see module, and when you go into the module, you will see Ethernet ports. You right click one of the port, you will see all these options. If you want this port to be a server port, then see, initially it will be unspecified. You see at the background, unspecified, unconfigured. You can configure them as a server port or uplink port or FCOE uplink port, FCOE storage port or appliance port. Any of this. Is it easy to understand now?
Yes. Yeah, makes sense. The only thing that I do have a question. When it says uplink, I see you have two options. You have uplink port or fiber over ether channel uplink port.
Yeah. If the upstream switch, if my upstream switch don't support FC over Ethernet, then I cannot configure it as FCOE uplink. I should configure it as simply uplink. If my upstream means, if the nexus switch on the top, which I am connecting my fabric interconnect, if I am configuring that also to carry FC over Ethernet, then I can go with this option, FC over Ethernet. It depends on how you want to use the uplink. If your uplink is going to carry only the Ethernet traffic, then I'll configure it as uplink port. If I want the uplink to carry the FC traffic over Ethernet, then I need to configure the uplink port as FCOE uplink. If I want to carry the FC over Ethernet, but it is not connecting to a switch, but it connects to a storage box, then I need to configure it as storage port.
Perfect. Now I understand it now. Thank you.
Welcome. You can configure fabric interconnect port to be used as a span port, which we just now saw, the mirror port. Next, fabric interconnect switching modes. Okay, you see, the fabric interconnect can act as a layer 2 switch, or it can be the default mode, end host mode. What is host? Computers, servers. They are actually end host. Now, according to the network on the top, Yeah. If I want this, the servers are connected here. Now, if I want this fabric interconnect to be seen on the upstream, by the upstream switch, let's say this is Nexus 5000 series. Connecting. If you want this switch to see your fabric interconnect as another switch, then we need to change the mode to switch mode from the end host mode. By default, according to the switches, this is not a switch. This is a big computer with many ports. That is why it is called as end host port. Meaning, this is not a switch. They are not subjected to STP. They will not block. Simple. They are a host with many ports. These are all servers, right? This fabric interconnect represents the servers. Hundreds of servers. So the hundreds of servers are seen through this fabric interconnect. So fabric interconnect will not be seen as a switch, it will be seen as a host. End host mode allows multiple active layer 2. See, will switch allow multiple active layer 2? No way. Because of STP, only one will be active, all other will be blocked. So end host mode, which is a default mode, allows multiple active L2 to forward. If you switch to switch mode, switching mode is not default. If you change the fabric interconnect to a switch mode, it becomes a Ethernet switch and they are subject to STP's blocking. So end host mode, that's what we see. There is no blocked ports. This is the fabric interconnect, what you see here. There is no blocking port, uplink edge ports. So put down. So no blocking in the end host mode. But if you switch to switching mode, if I change this to switching mode, then this is not an uplink port, this is a bridge port. Earlier what it was from uplink edge port, whereas now it is a bridged port. It's a switch, it's a bridge. So they are subjected to STP blocking. So did you understand these two modes? Fabric interconnect can be in an end host mode or switching mode.
Yes, I understand it now.
Alright, now if you are changing the mode from the default end host mode to a switch mode, or back from the switch mode to the end host mode, we need to reboot the fabric interconnect to take effect, to become the mode that you want. Now, it's about pinning. This is about pinning the servers. Mapping the servers is what I mean, pinning the server. I told you by default the fabric interconnects are in an end host mode. And what we see here, the servers are mapped or pinned. We can see these 4 servers have got a straight line, whereas to this fabric interconnect they have dotted line. Inactive, active. So out of 8 servers, 4 servers are active on this fabric interconnect A, the left hand side one. And also we see the uplinks, both will be forwarding the traffic. I got 2 uplinks, one to Nexus, let's say Nexus 7000 series, first one, Nexus 7000 series, second switch, N7K1 and N7K2. So what happens now? The traffics are going to both the network device on the top from the end host. No blocking. That's the good part. We may also do this type of pinning. See, they are using the word pinned, same like what I used. Pinning, pinned. Here, the VLANs that are allowed here in this link is only the VLAN to which this server is mapped. So this server traffic can go to Nexus 7001 series, Nexus 7000 series, Nexus 1. The other VLAN traffic, the other servers go through the other Nexus. So the pinning of this server is to this uplink. It's pinned to this uplink port. Whereas these servers are pinned to this uplink. This uplink from the fabric interconnect towards the north. Again, this is not dynamic pinning, this is static pinning. Statically we can pin, we can map. Right, now what we see is all the servers are pinned to the uplink. So the traffic is load shared. All 4 servers uses the 2 Nexus switch on the top via fabric interconnect A. If the fabric interconnect A goes down, I forgot to tell one story, so I'm trying to. Right now this is inactive. This is inactive for this particular 4 server. The other 4 server may be active on this. They have not shown in the picture here. Right now this is inactive for this 4 server. Because pinning is done only on these uplinks and this switch. If this fabric interconnect goes down, what will happen? Because they are not pinned to this, the failover won't happen. So when you are doing manually pinning, you need to say this will be the active and this will be the standby. Something like that. Or master slave or primary, secondary or backup, something like that. So these are all static pinning. Static pinning, if you are pinning it statically, make sure you got a standby configured so that the primary mapping goes down, the port that is mapped primarily goes down, it will go via the secondary. But there is a dynamic pinning, that's a good news. We will talk about the pinning in a separate chapter. I'm just giving you an idea. In dynamic pinning, in case if this goes down, automatically all will be pinned to this. Automatic. That's dynamic pinning. Leave it to default. Ethernet enhanced mode. End host mode. End host, not enhanced. End host mode. The mode which we are talking about now. The default mode is end host mode. Unicast traffic loop prevention layer out for server link is pinned to one uplink port. See, even if it is a static pinning or dynamic pinning, please focus. Static pinning or dynamic pinning, the server links is pinned to one uplink port, not too many. So loop will not happen, you see. When will we have loop? when we got multiple interfaces of same VLAN, redundant interfaces of same VLAN, then only loop will happen. When one server is pinned to one uplink, how the loop will happen? No possible. Not only that, local switched for layer 2 traffic. So for the layer 2 traffic, the traffic need not to go to the upstream northbound devices. If a server from here wants to talk to a server here, it is locally switched. And it also uses the reverse path forwarding and deja vu check. There's also another pronunciation for this. Deja vu check. Okay. What is deja vu check? It checks whether there is a redundant port mapped to one single server. If it is there, it will discard one and it will have only one port for one uplink port for one server. One uplink port may be mapped to many servers, but it won't be mapped to multiple uplinks. Servers won't be mapped to multiple uplinks. One server will not be one port can be mapped to multiple servers. One uplink port can be mapped. Multiple servers may be using one uplink port. But you will not see one server mapped to more than one uplink port on one fabric interconnect. That's what deja vu check. And also it does reverse path forwarding to find in case if the packet is coming from the north to the south, it knows via which fabric interconnect it has to forward, via which port it has to forward by using the reverse path forwarding. How the packet came, the same way the packet should go back. Any question on this?
No. What I'm understanding is the purpose of that deja vu check is to make sure that you don't have multiple uplinks.
Correct. To avoid loop.
Okay. Loops, yeah, because it's in a host.
In the host mode.
Yeah, got it.
We don't have spanning tree to prevent loops, so this is what prevents the loop. Local switching for layer 2 traffic. Server is pinned to one uplink port. Server is pinned to one uplink port. Local switched layer 2 traffic. Reverse path forwarding and deja vu check. These are the ones that prevents loop in an endorsed mode. You are talking about objective type question, 4 questions before the lab. You may expect this type of questions.
I see.
Next, unicast traffic rules to prevent loop. Each server link is pinned to exactly one uplink port. We have seen that. Server to server layer 2 traffic is locally switched. Traffic from one server to the network goes out is pinned to the uplink port. So anything that goes to the north port goes via the uplink port. Server to server is locally switched. Next, the fabric interconnect forwards the traffic from the network to the server only if it arrives on the pinned uplink. That is what called as reverse path forwarding. See, A is talking to B. A is a server. A is a server. It talks to B somewhere here. Now B responds. If B comes back to the same port via which it was sent from A, only then it will forward the traffic. Otherwise, it will simply drop the traffic. See, the fabric interconnect forwards the traffic from the network. From the network means what? From the north to the downstream via the fabric interconnect server only. It arrives on the pinned uplink. That's what called as reverse path. Server traffic that is received on an uplink port except the pinned uplink. If it is coming except the pinned uplink, it will drop. Dropping that because it didn't satisfy the reverse path forwarding rule. That is what taken care by Deja check. What did I say for Deja check exact? Sorry, I said wrong. It's in the previous slide I said checking whether there is more than 2 uplink port. No, that is not Deja check. Deja check is it coming on the same path where using which it was sent? Checking that is what called as reverse path forwarding. This is another word to call it as Deja check. Only if it is satisfied the reverse path forwarding, the packets are going to be forwarded. Otherwise, it will be dropped. That is what called as Deja check. So please correct it. What I said is wrong earlier. Deja check is server traffic that is received on the on any uplink port. Received means from the north it's coming down to the uplink port, except it is pinned uplink. If it is coming on the other ports other than the pinned port, then it's going to drop. This rule is what called as Deja check. Is it clear?
Yeah, this reminds me of the firewall.
Yeah, there also.
You know how it drops packets if it doesn't come from the same return traffic.
Yeah, correct.
I see. Yeah. Interesting.
Correct. RPF in firewall is. RPF in firewall we have this. Multicasting also uses this RPF. Next, multicast and broadcast loop prevention. So we saw unicast traffic. Multicast also, if it is going to multicast, it will multicast within that VLAN member. The incoming broadcast traffic is pinned per VLAN basis depending on uplink VLAN member. So if it is a broadcast traffic, it will not broadcast to all the VLAN, it will only broadcast within those uplinks that are in the same VLAN membership. Next, IGMP multicast, Internet Group Management Protocol multicast. Groups are pinned based on the IGMP snooping. Each group is pinned to exactly one uplink. So again, IGMP snooping here, it means the information that is collected in the multicast routing table. If the multicast routing table says this is the incoming interface and this is the outgoing interface for this multicast group, only on those groups the multicast traffic will be forwarded, not on all other ports. The IPM route table is what called as IGMP snooping table. Next, server to server multicast traffic is locally switched. Fabric Interconnect applies the reverse path forwarding and Deja check for the multiple traffic as well. So not only for the unicast, even for the multicast traffic it uses RPF. So automatic pinning is the easy and best one. You see, if one of the link goes down, automatically the traffic will be failing over via the other link. The server traffic will go via the other link. That's good. If both fails, if both the uplink that are going from the fabric interconnect goes down, now you see this all become dotted line and this became through line blue. It started going via the fabric interconnect B. See the previous slide? These are all dotted lines on the right hand side. Only when all the uplink goes down, only when all the uplink goes down, the fabric interconnect B becomes active forwarder. This is automatic uplink pinning. Static pinning is also possible. We'll talk about that later. Now, disjoint layer 2 network. So to prevent loop, what we do is, by default on the uplink, all the VLANs are allowed. We need to say what all VLANs we do not want to forward. That is what called as disjoin. Disjoin, when there are physical and logical layer 2 network domain upstream that are not interconnected and cannot be accessed for all UCS fabric and all. So by default, the uplink will support all VLAN traffic. We need to disjoin. We need to say VLAN 3040 not allowed. What does it mean? It means only VLAN 20 is allowed. Disjoin. This is one of the method in which we can pin traffic to the upstream. But there is also another method which I will show you in the lab demo, where we will be creating VLAN groups, and we'll map the VLAN group to the interface. So these are the two methods. One method is you use the disjoin method, or you create VLANs and put it in a VLAN group and map the interface to the VLAN group. That interface, that uplink interface will carry those VLAN traffic. So VLAN manager configuration. Fabric Interconnect still enables all VLAN. This I finished saying that. We can assign a particular VLAN to the respective uplinks. For that you need VLAN group. Cisco UCS Manager removes the disjoint VLAN from all other uplinks. So you can also create disjoint VLAN and say these VLANs not allowed. Does not explicitly allows the disjoint VLAN on their associated uplinks. Rather, it disallows the disjoint VLANs, which I explained already. So, best way is create VLAN, put them in VLAN group, attach them to the uplink port. That's one method. Another method is create a disjoint VLANs, apply to the uplink port. So those VLANs only won't be allowed. Two methods. So this is exactly what I was telling about VLAN groups. This is the recommended one. Configure VLAN group and assign them to the uplink interface. Assign VLAN group to the uplink interface. UCS Manager allows only those VLANs to the configure uplink. So this breaks the rules that all VLAN should be enabled on all uplink. Controls exactly which VLAN belongs to which uplink. This configuration method is recommended because it is more intuitive. So we follow this method, not the disjoin method. Is that clear? The VLAN configuration and disjoining.
Yeah, it's becoming clear to me. Yes, it's new but clear. Yeah.
Yeah. So by default, all interface should carry all VLAN traffic, but we don't want all VLAN traffic to go via all the ports. So we can say disjoin these VLANs, so it will get disjoined from that interface. The other method is we create a VLAN group and say only these VLANs in the group should be forwarded via those uplinks. So that breaks the rule saying all VLAN should be available on all uplink. All VLAN should be available on all uplink is the default rule. That's why we were using disjoint in the previous. So if you want to break this rule to have control over which VLAN goes via which uplink, we need VLAN group. So these are the demos we need to do. This will be the second lab. The first lab will be we go under the interface and specify whether it's a server port or a network port or a FCOE port or an appliance port. The second lab will be creating VLANs and mapping to those uplink ports. No, the first lab what we did, we defined uplink interfaces. You may also have a port channel. You can take multiple uplink port and bundle it. So now we need to map the VLAN group to either the physical interface or the port channel interface. That's the second lab, VLAN groups, assigning VLANs to the uplink. Yeah. Now, what we are going to see is C series. C series is rack mount. As I said earlier, SIM-C is an operating system. C is a graphical user interface. It's a manager for C series. You see, SIM-C stands for Cisco Integrated Management Controller. So this is the one which is controlling the rack mount servers. But you can also manage using UCS Manager. But if you use UCS Manager, Cisco SIMC will not be used to manage the server. So you can use UCS Manager. Our main focus is UCS Manager. Our aim is not to use SIMC. We are already using UCS Manager for the B series. What if my company have got some C series? I can still integrate them. That's what we are trying to do. UCS Manager integration options. So you can have one UCS means one fabric interconnect, or cluster of means two fabric interconnect. If you have only one fabric interconnect, it's non-cluster. So one fabric interconnect is connected to the C series. It's the same story which we saw earlier in the B series. You may have a cluster or you may have only one fabric interconnect. But if you are having a cluster, there are some options. If you are having multiple fabric interconnect, you have some options which we are going to see. So to manage that UCS Manager connection options, you have dual wire management, single connection, and direct connection mode. They are just the topology differences. Let me show you the picture and then I'll come back to this one. You see, when establishing the physical connection for the rack server, must specify the policy first. Correct. The policy. The management policy is global to all the C series rack mount server. We define the policy using the UCS Manager, and then connection policy determines the rack server discovery in the manager. We will be having more clarity when we do such labs with the C series. On the lab guide which I shared with you earlier, it starts with exactly this policy lab, and then it will discover the C series. Now, UCS Manager connection policies of two types: auto acknowledge, user acknowledge. Yes, when you configure policy, we define this. Auto acknowledge is recommended and default user UCS Manager discovery, and manages the servers as soon as the connection is established. As soon as we connect, it recognizes. Whereas here we need to manually acknowledge. That's what user acknowledge. This is the policy. Now, to change the connection policy, you need to decommission and recommission whenever you do changes to the policy. Now, this is what one way. You have two FEX, means Nexus 2000 series, and two fabric interconnect on the top. We're using two physical NIC cards from the UCS. This is one method. C series in a cluster setup. Next, non-cluster setup. Same 2000 series, only one fabric interconnect. We got a port channel here, and we got only one link. This is UCS with non-cluster, single. And then directly connecting the UCS server to the fabric interconnect. Without any FEX, without any 2 keys. Or, see, this is two fabric interconnect. This is single fabric interconnect, just directly connecting back to back, non-cluster. So these are the 4 different types. 1, 2, 3, 4 types. That's what I explained here. Single connection, direct connection mode, dual wire mode. Okay. So demo we have to do this uplink. These are the 2 demos we need to do: uplink and then VLAN manager. Yes, that's it for the day.